Welcome to the Basics of Python. This is the fourth lesson. And for today, we want to teach about type, determining the data type of a variable or an input, and then converting between these data types that we learned in the previous lesson. And then we want to go through while loops, and finally, how to break these while loops. So first, we're going to cover the type function. So how the type function works is you just put type, and in parentheses, you want to put your input. And in the bottom, we can see an example of this with the input hello world. This would tell me that the type for hello world would be string. And if I were to type this into REPL directly, you will see an output of class string telling us that hello world is a string. So if everyone's not currently on REPL, I'd like everyone to open up REPL and type this in. If you also want to follow along with Oscar and see if you have it right, he's also screen sharing on Zoom. Okay, so let's move on. So what is this type useful for? Right? So it's good for determining, oddly enough, it's good for determining variable types. As you can see, when you print 51 and the string 51, on console, they look exactly the same. And without type, you wouldn't be able to tell the difference. So who cares about that? Well, reason why people care about this is it's different. Like that the first 51 and the second 51 are different data types, and thus the operations you can perform on them are also different. As you can see on the first line, when I add 51 to 50, I get 101, as both of them are integers. However, I cannot add the string 51 to 50, and thus it will throw an error. In this way, type function is good for debugging your code and seeing why errors are being thrown if you are converting to the wrong data types. Converting between types, how exactly do we achieve this? Type converting is essentially just converting between data types. There are 4 type conversions for the 4 data types that exist. Now, if we remember from our previous lessons, these data types are booleans, strings, integers, and floats. And each of these follow different rules for conversion between other data types. And so the syntax for any type conversion is essentially the data type symbol, which is which one you're converting to, and whatever input you want to put in, such as like a variable or even just like a string that you want to convert to, say, an integer. In the example here, we have str for string and a variable that you want to be converted into a string. Type conversions for each data type are str followed by brackets to convert to a string, int with brackets to convert to an integer, with brackets to convert to a float, and bool with brackets to convert to a boolean. So now, what exactly are the rules? Like, what happens when you convert something to another data type? So I will now give a quick summary on what happens exactly. But for this part, I would like you to look along on the screen share with Oscar as I describe what happens. And I would like you guys to type it into REPL and run it for yourself and just see what happens, which is the best way to learn for this. When converting from a Boolean to a string, essentially it just becomes a string version of either true or false, as Booleans can only be true or false. If we were to print the type of either of these, you would be able to see that they are string. However, in the console, they will look almost exactly the same. This tends to happen with a lot of strings, making the type function absolutely necessary to determine what type of data type you're actually working with. Now, when converting from a float to a string, whatever value is inside the float, that is the float, will be converted into a string. However, any zeros that are really unnecessary to the value will not be converted over to the string, and thus we see 10.45 instead of 10.4500. When converting an integer to a string, it follows about the same rules as a float. It just turns the number into a string, and they look exactly the same on console, but now they follow a different set of rules and behave differently. So now Boolean values, if we can remember, are either true or false. This makes the conversions between other data types and Boolean variables a bit wonky to say. So for integers, it is anything with any value that is not the number 0 will give you true. And that works for literally any integer value. And any value that is 0 will give you false. Therefore, false would be 0 and any other number would return true. Floats here apply the same rules as ints. If the floating point value is 0.0, it will return false. Otherwise, no matter what value you put in, it will return true. And both of these are really useful for checking whether or not you actually have something. So like if you're checking for a mathematical equation and you're checking to see whether or not it has a possible solutions, you can analyze and see whether or not solutions is equal to 0 and thus return true or false to whether or not there are solutions. For strings, it will only return false if the string is empty, as you can see on the third line, third example. And even if you have 0, put in 0 for a string, it will also return true as the string is not empty. And this is what I said earlier about different data types following different types of rules, and that's why it's important to determine their data types. So now when converting from string to integer, essentially what happens is if the string is a number, it will turn that into an integer and cut off any unnecessary zeros. As you can see in the second example, it cuts off the 0 from 042 and just converts it to 42. However, if Oscar would care to demonstrate, if you put in anything that's not a number into the string and try to convert it into an integer, it will throw an error. This is because you just cannot do that. There's no way to convert E into a number unless you get into some more complicated Python mechanics, and we will not do that right now. Now, converting Booleans into integers. So in computer language, what zero binary, if you've heard of it, consists of only zeros and ones. A 0 is false and a 1 is true. 0 is off, 1 is on. And thus, when you convert a Boolean true into an integer, it'll return 1, and a Boolean false into an integer, it'll return 0, much like binary. Oscar, when you are copying it down, could you just create a new one every single time so that there's a little history? Thank you. All right, so when converting a float to an integer, what happens is that it cuts off the decimal point and the decimal numbers behind the integer. This does not mean that it actually rounds it. As you can see in the second example, 53.76, if that was rounded, it should display 54, but it doesn't. Python, what it does is it just cuts off the decimal places in the back, and thus it would go round down to 53. Okay, now converting to float. So when converting an integer to float, it's pretty basic. What happens is it just adds a decimal place and then adds the first decimal and just leaves the number as is. So as you can see, that is what happens. And the numbers still operate about the same way. So this probably isn't also the most useful conversion, in my opinion. So when you convert from a string to a float, something similar to int happens. And what happens is it converts the numbers from a string into a floating point value if there's a decimal place. If there is no decimal place, I'm pretty sure it will add a decimal place for you and put a 0. Just like an integer, you cannot have letters or characters in if you want to convert it into a float. So now we're going to be converting from Boolean to float. So a Boolean would just be true or false. And much like an integer, it just converts into a 1 or 0, except this time with a decimal number following it. a decimal point and the first decimal number, it's almost the same thing. And we're going to have a little practice problem. That's all of the conversions. I don't expect you to remember all of them. Some of them are more useful than others, but I do recommend knowing string to int conversions and int to string conversions are probably the most helpful that I found. So here's the practice problem. I want you to define the variables shown to the right, and then follow the instructions to print out the expected values. And I'll give everyone 5 minutes to do this. So Nicholas, if you could tell us whether or not you'd like more time or, oh, okay, that works. Okay, moving on. So now let's talk about while loops. So for a while loop is a while followed by the condition it needs to meet in order to terminate the while loop, right? So a while loop is consisted of 3 components. So it's first, you have the start condition. And as you can see from the example to the left, that would be line 2, and where we set the value x equal to 0. That's where we start. Then you would need an end condition, and that's present on line 5. That condition is if x becomes greater than or equal to 10, it will terminate the loop. That's why the loop says while it is less than 10. And finally, you do need an increment so that your start condition can meet your end condition and your loop will terminate. And this can be seen on line 11. And that following code, it puts the following on console. So for a while loop to terminate, we can also have multiple conditions, and these can be separated using and or. So if you use an and, it is saying that while x is less than 7 and y is less than 5, meaning that if one or the other fails to meet these conditions, the loop will terminate. However, it is different with the or, where x is less than 7 or y is less than 5, at which only one of these conditions needs to be met for the loop to keep running, which is why this loop iterates more than this loop. As you can see, as soon as y hits 5, the loop terminates. However, this loop here does not terminate until x is greater than 8, in which case it iterates 2 more times than the previous one.
And if Ben wants to go back a slide, one quick thing to note is that the plus equal sign you see next to the variables x and y, that's just shorthand for x is equal to x plus 2. So it's basically just a quicker way of writing it, so you don't have to restate the variable name several times.
So with operations, instead of going x is equal to x plus 1 or times 1 or divided by 1, you can go divide equal, times equal, or plus equal, and it will achieve ultimately the same effect. So I'd also want you to be careful. If we're going to be printing or doing something with the increment value, in this case x, it's important where you put the increment in the loop. As you can see on the example on the left, the increment is below the print statement, and on the right, it's above. This could result in misprints on the console. As you can see, they have different outputs, and this is because it increments before it prints it, and thus does not start at 0, but rather starts at 1, and does not end at 9, but rather ends at 10. Okay. So this is an even bigger problem than that. This one is called an infinite loop. And an infinite loop in coding can occur when the end condition never becomes false. So it would be infinitely true. And this will break your code, and it will break your computer. As your computer, your computer will attempt to run the code. It will never finish, and it will cry. And then your memory will also not do too well. And here is an example of an infinite loop. So on the left, while true, and as you can see, true never becomes false. And so the computer will forever add 1 to x, and print that number. And on the right, that condition will always be met, as X never decreases, it only increases. And thus the same thing will occur. So we're going to do some practice. The instructions are to the left. Go through all the numbers, print the value followed by if they're even or odd. And if you do this correctly, your output should look something like the code on the right. And for those of you who are done, just play around with the while loop a bit, add a condition, subtract a condition, just test it out and see what happens, really. Have some fun. For this, I think we're just going to have to go through the solution.
So I'll just start by modifying the basic while loop. So you're gonna start from 1. You want to go through, and then inside the while loop, what you want to do is first you want to create an if statement to check if it's even. So you can just say if x mod 2, and you want to print x, and then along with that you want to print even. Just copy this code and change the 0 into a 1 to check if it has a remainder of 1. And then if so, you just want to print odd with that, and then you can keep the increment the same. And then also another thing is you want to change the condition to x is less than 11, because it will only run numbers up to 1 less than this, or alternatively, you could say x is less than or equal to 10. So it'll also run when x is equal to 10. There you have it, the solution.
Great. Thank you, Oscar. So the solution will be up for about 30 seconds. If you want, copy it down. So now we will look at alternate ways to modify while loops. And this comes in the form of break and continue. Now, break and continue are keywords in Python. And if you look on line 5 on the example to the right, they look something like that. They'll turn blue, I believe is the default color. Break statement will terminate the loop, and thus if it is reached, the loop will stop and it will jump to the first line outside of the loop. In this case, that would be line 8, and it will print done. This is because the first time this loop runs, x is equal to 1, and since x is not an even number, the loop will break and thus jump to line 8, printing only done. So the second keyword is the continue keyword. Unlike the break keyword, it doesn't actually quit the loop. What it does is it skips the current iteration. So as this loop is set up, if a number of iteration, which is x, is odd, it will skip printing it and repeat the loop from line 3 once again. In this way, it only prints the even numbers, and once the loop finishes, we'll print the first thing outside of the loop, which is done. The benefits of break and continue is, for break, it saves time. It's if you have some code in the bottom that you don't want running, or like if your loop can terminate before, you don't want your computer just running that excess code if you have already determined a solution, and thus you would like to break the loop and print out your solution. This will save you a lot of time. This also serves as a secondary termination condition, as if you attach it to an if statement, it can also just be like, if this condition is also met, you can just break your loop, such as if you found your answer. The continue statement, much like the break statement, also saves time. It's if you found something, a solution, and you've already determined an answer for this current iteration, you can just skip it instead of running all the other if statements, and this will save your computer time, as it doesn't need to process excess for loops, excess if statements at the bottom. And naturally, this will reduce the amount of if statements, as continuing will just cause the rest of the code not to run, and thus you can, instead of an else statement, you can have your second condition underneath the continue if the first condition is met. So we're going to give another example so you can try out these keywords. Create an infinite loop and check if the number is divisible by 3 or 5. If it's divisible by both, stop the loop. And if no conditions met, print out the number. I'll give everyone about 4 minutes.
First, you want to set your increment variable equal to 1 because that is the starting value. And then to create the infinite loop, I'll just use while true. Now, basically, what this does is that every time it goes to check the condition, it will always be true, so it will just keep on running. Now, next I'll define 2 more variables, which are equal to whether or not x is divisible by 3 or x is divisible by 5. Now, the reason I'm doing this is because these 2 conditions will appear a lot in the code later on. So if you just define them now, you'll save yourself a lot of time by not having to write out x mod 3 is equal to 0, and can instead just write the variable names. Now, the first condition we'll check for is if 3 and 5 are both true, in which case we'll just break the loop as for the problem. The next set of conditions we're going to do is determining what to print out. So start off by just saying if 3, print 3 as per the problem. Now from here, there's a few ways you can do it. Either you can use continues, or you can use elif statements and else statements. I'll be using continues. So you can say continue, which will just move it up to the next loop. And then from here, we'll do the same thing for 5 and check that condition. And now, instead of having to check that 3 and 5 are both false to print x, because we already use continue, we know that 3 and 5 are both false if we've gotten to. So you can write print x, and now what you don't want to do is you don't want to put the increment at the bottom, because what will happen is that once the continues run, once you reach the first continue, you'll get an infinite loop. So instead you can just put it at the top for this example. So you can just say x plus equals 1 and then start at 0. So if you run this code, you'll see the solution printed out. I'll give you guys a second to copy that down if you want, and then Ben can continue.
As you can see on line 10 there, that is the secondary condition, termination condition. So the first termination condition will never be met. It's an infinite loop. But the second termination condition can be met, and thus break provides us with a secondary condition. Moving on. Okay, I will do the screen share then. All right, I promise this Kahoot's better than last week's. This one's actually play tested, and we reviewed the questions just to make sure they work. Okay, so remember what type prints. It prints type and not exactly the variable or input itself. Remember that. Oh, a little misconception here, I guess. The type function itself doesn't really convert data types. What it does is it tells us what data type something is. And thus, because of this, it is very useful in debugging. Data type conversion happens only with bool, string, int, or float functions. Remember, when you're converting to an integer, you cannot have letters. And when you're converting to a Boolean, any string that is not empty will be a true. Okay, float and int have about the same behaviors. So both of them will throw an error if you put a letter into them. Okay, so if I'm saying if x, essentially that would not be acceptable. Just that value could never be met, especially if it was just true, and thus it just wouldn't be a thing. The reason this creates an infinite loop is if you have your start condition inside the loop, and every time the loop runs, x is set back to 0, the loop will never finish. And since there is a print statement in that code, it will continuously print to the console until until REPL itself just decides that it's had enough and terminates your loop for you. Yeah, red's a funny answer, but that is definitely not correct. Okay, glad to hear that. And yeah, it seems to be improvement. Okay, that is it for today's class. Hope everyone learned something and enjoyed their time. And I look forward to seeing everyone next week. Yep. Goodbye.